Hi, hello, my name is Paul Watkins. I am a Senior Product Manager at Instana, and along with my colleague Amit, who will introduce himself in a moment, we're going to introduce you to the new Instana Intelligent Investigation Incident Investigation using Agentic AI. So, Amit, would you like to introduce yourself?
Yes, thank you, Paul. So my name is Amit Rahane. I'm a data scientist in Instana, and I've been working on the investigation framework for the last couple of years.
Okay, so I want to set the scene before we go into the technology. And, if we think before we talk about the outages are expensive, the main aim or one of the primary goals of an observability solution, such as Instana, is to help our customers reduce their mean time to resolve incidents. Okay, because as we say here, outages are expensive. Average cost of IT downtime at over $5,000 a minute. Average time to resolve more than 4 hours per incident. Now, I remember talking to a customer a few years ago who's involved in shipping oil. And I was asking him about, the cost of downtime. And he told me that for a particular application, if it was down, they couldn't ship oil. It cost $24 million an hour. So there is, potential for huge expense if you have application downtime. However, the thing that complicates that is that application complexity has dramatically increased in the last decade. And even before that, application architectures were relatively simple. They didn't change very much. And these days, with the rise of containerization and so on, we've dramatically increased the complexity. And with that, when we introduce change, the risk of inadvertent downtime with those changes has dramatically increased as well. So modern applications now have more than 200 dependencies on average, and some many, many more than that. So our aim with the Instana Intelligent Incident Investigation with Agentic AI is to help our customers reduce mean time to resolve incidents. Now, the piece we're talking about, the intelligent investigation, can't address all of the mean time to resolve, but what it does is dramatically reduce the mean time to diagnose an incident. Okay, there are other capabilities that we may touch on that help you with the resolution part. And Instana is excellent at identifying incidents automatically through its very granular data collection and the ability to in near real time analyze that data, identify incidents. Then we can do the intelligent investigation, which dramatically reduces the mean time to diagnose. And then we have automation capabilities, intelligent automation capabilities, to help you address the resolution part. So the whole aim here is to reduce mean time to resolve. We're aiming to help our customers reduce the mean time to diagnose by as much as 80%. Could you move on to the next slide there? So where we are today. So Instana uses causal AI and can identify the probable root cause of an incident. Okay, so it uses all of much of the data that Instana collects to enable it to identify where the most likely cause of your incident is. It identifies the entity, it identifies the what. Okay, so very quickly identifies the source of the fault. And this helps to reduce that investigation time dramatically. We also in Instana today offer AI-powered incident remediation, which automatically recommends action enables you to generate policies and actions to resolve incidents, and suggests automation fixes where possible. Now, if you already have code, you can import that in. But we also provide this generative AI-driven remediation capability. Also, in incidents, we provide incident summarization. Again, it's generative AI-driven. It provides a point-in-time summary of what's going on in your incident. Now, if you think of an incident, they have a life cycle. Things can get worse as well as better. So every time you generate that summarization, it will be up to date at the point of time you requested the summary. So it captures key details and progression and aids in post-incident analysis as well as reporting. Okay, as I said, we are here to drive faster time to resolution and reduce the operational burden on SRE teams so that those valuable resources can be used to improve things like application architecture or improve reliability and performance of your applications moving forward. So that's the introduction from me. I'm going to hand you over to the very capable hands of Amit, who's going to show you or talk to you about where we're going and how that will benefit you as well. Thank you.
Thanks so much, Paul. Yeah, so as Paul was saying, we've introduced the probable root cause feature roughly a year and a half ago now. And that allows us to show where the fault has been propagating from. But this on its own is just a signpost. To truly understand this incident, you need context. So over the last year, we've been building context within the incident page for the probable root cause. So Instana automatically now enriches the probable root cause with a wealth of system information, notably logs, traces, events, and metrics. So we correlate these modalities of data that are relevant to the incident and show that front and center to the user, which eliminates the need to jump between different tools, different dashboards, etc. You should be able to get the full picture right from the incident page. And so this impact is significant. By providing this correlated context, we further reduce the mean time to resolution, cut down on the noise, and break down some of this fatigue that SREs face at 3 in the morning, where they're looking through 1,000 different dashboards and trying to find the logs, trying to find the events, trying to find the relevant information for each of the entities that we think are relevant to them. So that empowers developers and SREs to conduct a much more efficient investigation. This context is even more powerful when you provide it the information about where it lives in the application topology. Modern applications are all about dependencies. I think, as we mentioned on the first slide, dependency growth is exploding. This is where topology comes in. Instana automatically discovers and maps the components of your system and the relationships in real time, which allows you to see right front and center on your incident page the services, databases, containers, etc., and how they connect to your probable root cause and how that might connect to your incident that has occurred. So say you have an incident is just, oh, high error rate. You want to see how that connects to the probable root cause that was identified and any logs that might occur on the probable root cause. The topology plus the context gives you that front and center. And this allows you to dynamically highlight the impact path, which shows you exactly which components are affected and drive towards that blast radius. Okay. So we have a probable root cause, a rich context, and a topology map. We have a lot of information already, right? But we can go deeper, and we should go deeper, because even with this information, the SRE is still tasked with identifying what the true cause of this investigation is. They're tasked with going through all of these logs, sometimes at 3, 4 in the morning, right? With millions of dollars on the line. These SREs are tasked with a very hard problem. So to kind of speed that process up a little bit, we want to drive at two more questions. And that is, why did this incident occur? And what is wrong with the application? Understanding the root cause isn't just about finding the broken component. It's about explaining why it broke in the context of the system history and behavior, and what exactly is wrong with it. So we need to move from identification to explanation. And that's where AI agents come in. Agents can help us bridge this gap by performing complex reasoning, understanding incidents conceptually, navigating those complex topologies that we just saw, and recognizing patterns that they've seen from Stack Overflow or whatever. These agents are trained on the history of the internet, right? They have a lot of information there that they can show us. They can automate the very process of investigation. But given how complex the system is, given how complex the application is, how do we build and test this kind of agent? We need a realistic environment to train and evaluate it. And that brings me to something I am particularly excited to share with this audience, ITBench. ITBench isn't just a data set, it's a complete evaluation ecosystem for AI and IT operation. And it's fully open source. The paper is published and the repository is public. I encourage all of you, especially students and researchers, to check it out, contribute, and use it in your own work. It provides realistic environments with actual application stacks and observability tools. It includes diverse scenarios that cover not just reliability, SRE, but also security and FinOps. And it offers a comprehensive evaluation framework to measure how well an agent performs. This open architecture is designed for community collaboration. So now with ITBench, we get an exhaustive scenario set that we can use now to build and test agents that live in this environment. And we can identify, one, how good are baseline agents? How good are just like LLMs? And what do we need to do to make these better? Interesting. Okay. It seems there's a bit of an upload issue, but what does an agent operating in this environment do? It follows a classic loop: observe, reason, and act. The environment, which in our case is the application stack being monitored, produces observations, which is metrics, logs, and traces. The agent takes in these observations along with its memory of past actions and reasons about them. It then decides on an action to take, which is executed by calling a tool from its toolbox. This toolbox is powerful. It contains tools for natural language queries of telemetry data and NLTK traces and NLTK logs, for interacting with Kubernetes and NLTK kubectl, and even for generating security policies or runbooks. The agent uses these tools to interact with the environment, gather more information, and move closer to a solution. And using this ITBench ecosystem, we can benchmark the performance of current AI models on these complex IT tasks. And from this, we see the success rates. We're still in the early days. For complex SRE tasks like diagnosis and mitigation, which are the tasks that we're interested in here, current models succeed about 11.4% of the time. For security policy generation, it's about 25%, and for FinOps cost analysis, about 26%. This isn't a critique of the models themselves, it's a reflection of the immense difficulty of these tasks. Again, we have a lot of context, more context that will fit in the context window, more context than any of your biggest models, your Geminis of the world. None of them would fit all of the context that exists in a system in their context limit. So these numbers show us that there are fundamental gaps in AI capabilities when it comes to enterprise IT. Simply connecting a large language model to a system is just not enough. And so now we apply our learnings. The gaps revealed by ITBench show us where we need to focus. Our goal is to create an agent that is specialized for the task of incident investigation. And so enter the Instana incident investigation agent. It's crucial to understand that this is not just a general purpose chatbot. It's a purpose-built diagnosis agent, engineered on the technical foundations of our research in collaboration with IBM Research. It combines the structured analytics that Instana is known for with the reasoning capabilities of LLMs. So at a high level, when an incident is triggered, the agent's first step is to leverage our existing fault localization capabilities to get an initial starting point. From there, it constructs a mental model of the problem space. It takes in the logs, the errors, the events, all of this context that we have built over the last couple of years, and it feeds that to the agent, and it uses that to generate an understanding of the problem space of this incident. And then it starts a systematic investigation. It looks at each of the entities that were identified with probable root cause and traverses out from there. It identifies what it wants to look at next. It looks at what tools are available to investigate each entity. And then it uses these tools to collect evidence from the rich Instana data. Based on this evidence, it forms a theory about what is wrong with that entity. This process is a continuous loop of reasoning. So if you've ever looked at ChatGPT's O-series models, you'll see that it goes and reasons about your problem for a little bit. It might formulate a plan, it might do some Google searches, and then it'll take a few steps, formulate some understanding, and then give you back a response. That's exactly what we're doing here, but in this specific IT ops domain. This allows the agent to navigate the vast amounts of data with intent, prioritizing where to look next, and honing in on the true root cause. This allows us to go beyond just what is broken down to a coherent narrative that explains the why, which allows us to not only go to the source of the fault propagation, but also identify what might cause that fault propagation and the entire chain of events after that. So our goal is now to identify the entire fault propagation chain. So what's the impact? How will this help the SREs? This offers us a massive boost in productivity, and it's a fundamental change to how we manage incidents. Let's look at the before state for a second. The before state is an alert fires, an on-call engineer scrambles. They might open a dozen browser tabs, one for metrics, one for logs, one of traces. They might start up a terminal. And they're trying to manually correlate timestamps and piece together a story, all while the cost of downtime is ticking up. Now, in the after state, the alert fires, the incident it occurs, and the agent is immediately on the case. While the engineer is looking at the incident, the agent has already performed the initial investigation, analyzed the dependencies, and is already presenting a summary of its findings with a probable root cause and the evidence to back it up. The bar chart here is an illustration, but it represents the shift from hours of frantic manual correlation to minutes of guided analysis. And this has a direct business impact. It lowers operational costs, and most importantly, improves service reliability for your users. And further, we can now talk about democratizing SRE. Enterprise-grade reliability has traditionally been the domain of large companies with highly specialized senior engineering teams. This agent offers a force multiplier. It embeds the knowledge of a seasoned SRE directly into the tool, lowering the barrier to entry, allowing startups and teams with less specialized experience to operate highly robust and resilient systems. It frees up your most valuable time. And it allows you to shift from reactive firefighting to proactive system optimization and innovation. Instead of spending all of our time on Sev 1s, we can spend our time making the system better, as Paul was saying earlier. The investigation agent we've just discussed is the core engine, but the power extends throughout the entire observability platform. It's not just an isolated feature, it becomes the intelligent foundation for a host of new and enhanced capabilities. First, we talk about the chat interface. This is agentic chat, not just your generic chatbot. Because it's backed by the diagnosis agent, the conversation will be grounded in the reality of your system's data. You can have a meaningful dialogue, asking things like, what were the key events leading up to this memory spike in the cart service? Or show me the logs for the database during that incident. The agent can then provide these answers because it has already done the investigation. It offers a truly guided troubleshooting. Next, the agent's findings directly power incident summaries. Anyone who's had to write a postmortem at 3 a.m. knows how painful it can be. This feature automates that process, generating comprehensive reports that include not just a summary, but the key findings, evidence trail, and actionable recommendations. It can even incorporate notes from other tools, generating a single source of truth for every incident. And finally, automated remediation. This isn't just about running a predefined script. The agent's deep analysis allows it to suggest highly contextual fixes on each level of the fault propagation chain. It can propose specific remediation steps for the identified issue with built-in safeguards. So the plan for the diagnosis agent is to drive a more interactive, conversational, and automated future for IT operations. And finally, where are we on this journey? It's happening now in phases. Phase 1 is available next week.
Monday. Monday.
Monday, literally Monday.
Yeah.
This includes the single entity investigation, which integrates with the probable root cause context to give you that initial focus starting point. So that takes your probable root cause entity, fans out to the context that's provided, so logs, errors, events, topology, and generates hypotheses about what's going wrong. And we're moving quickly. Phase 2, which is what we've been talking about, is targeted for early Q3, which is where the full power of the agent really starts to shine. This will bring in multi-entity investigation that is truly topology aware. It will understand how different parts of your system relate and affect each other. And finally, enabling it to trace the fault propagation chain and deliver much more advanced why explanations. This shows our commitment to building on the solid foundation of Instana's core strengths, of all of the manual or semi-automated approaches that we've had in the past, and layering in more of the advanced AI capabilities to solve the real-world problems of modern application complexity. The journey from identifying problems to explaining or fixing them automatically is well underway. It's an exciting time for IT operations, and we believe these advancements will fundamentally change how all of us build and manage software. Thank you.
Yeah, so I'll just add to that. So for anybody who's interested, any from Monday, any existing SaaS customer will have access to that first drop, the single entity agentic investigation. Obviously, as a SaaS customer of Instana, as we release these enhancements going forward in early Q3, which, Q3 starts on Monday, so it'll be early in Q3. So they'll be accessible to you. For those customers that are self-hosted for Instana, we're working on a model that will enable you to access these capabilities as well. Now, you will need to be at a certain version of Instana in order to do that. And we expect that capability to be delivered in the Q3 timeframe as well. So, we want to make sure that all of our customers, whether you're SaaS or self-hosted, have access to this highly valuable set of capabilities that the team has been working for over a year, nearly 2 years to build. So I would encourage you to investigate that. If you would like to have a demonstration or would like to discuss it more, please reach out to us. Would you like to add anything further, Amit?
No, I think you covered it well. We'll be happy to take any questions.
Yeah. So we understand that the live stream is a little bit behind where we are, so we're just waiting for a question to come in. And Debasish is asking, do we have any demos? We have environments where we can demonstrate certainly the initial drop capability to you. I'm not sure. Amit, do you have anything with that shows some of the future or not? I'm not sure.
Yeah, I mean, we have some recorded demos, and we can share those with you offline.
Okay.
How does it train a topology? Do we have to annotate logs? Yeah, so we don't necessarily train on topology. We use the topology and give the agent access to guided tools. So the agent will be able to have access to, say, the same tools that an SRE would have access to in the Instana UI. Do we have to annotate logs? Yeah, go ahead.
Yeah. Sorry. No, I thought you'd finished. Carry on, Amit, if you've got more to say.
Yeah, for your second question, do we have to annotate logs? We don't annotate necessarily, but within Instana, we're working on a set of features to have like log identifying which logs are new and identifying like log templates that do help with log analysis, because there's too many logs at the moment, or like there's oftentimes when there's too many logs to stuff into context. So things like templating does help with that.
Yeah,
you're saying
exactly. Neil, I'm sure that we're working with the demonstration team so that we can give people access to these in the demonstration environment. Thanks for the question.
Okay, Dashant, how do we validate if the root cause is correct, and how do you prevent hallucinations? Good question. So I'll take those in the opposite order. So how do we prevent hallucination? Obviously, with any large language system, there's always a risk of hallucinations. So how we prevent them is twofold. One is highly engineered, very specific prompts that have been tested with ITBench to prevent hallucinations. And the second is using like self-reflection techniques. So there are self-reflection techniques that have been studied in literature that allow us to at least mitigate the chances of this. And how do we validate if the root cause is correct? That's why we have ITBench. So ITBench allows us to have a set of scenarios that we can test and make sure that our solution is performing reasonably before we roll out to a production setting.
But I think it's worth adding there as well. We do provide an indication of our confidence in the probable root cause identification.
Yeah.
Because the more data we have, the better we can identify the probable root cause. But if there is the less data there is, the less confidence we can have in that accuracy, right? So, but we indicate that within Instana.
Yeah. Okay, deep. Does agentic investigation capability pinpoint the root cause down to the level of an individual microservice within a distributed microservice topology, or just points the microservice which caused the error? So the agentic investigation actually goes a level deeper than that. Even it's able to isolate. It's able to isolate to, like, say, a config map, or say an endpoint or a process. It's able to look at basically any degree of granularity that we show in Instana today, and identify if that is in an error state and if that's causing an error state. Neil, what kind of Instana incidents does this AI investigation apply to? Yeah, we're going to start rolling out with what are known as application smart alerts. So application smart alerts are primarily on error rate and latency on an application perspective. So an application perspective is a grouping of services in an observability setting.
A logical view of an application based on the
We're not stopping there, obviously. So we're trying to expand out to obviously all types of smart alerts, as well as all types of supported Instana incidents.
Good questions. Yeah. Are there any more questions?
Okay, that's the end of the questions.
Yeah. Okay. So I want to thank you all for your kind attention. We believe that these capabilities that we've been discussing today will offer our customers dramatic benefits, helping them to reduce costs, both financial and reputational, especially if they're providing, obviously, services externally. We are looking for ways to dramatically improve and extend the use of agents in Instana, which will enable us to increase those benefits going forward. So, as I said, the call to action from the team is to reach out to us, ask questions, ask for demonstrations, and have a look at, if you're already a customer, have a look at your environment from Monday, and please provide us with feedback on how this is helping you.
Yep. Thank you so much, and we look forward to any communication that you have with us.
Amit, thank you.
Yeah, thank you, Paul.